This video describes how one of the world's largest manufacturers of computer chips, Intel Corporation, was tasked to bring down the supply chain cost of Atom within the affordability targets. Before moving to this video, just a humble request to you. If you like this type of content, please do like this video and share this video with your friends. It would indicate to me that I should continue to make these types of videos. Also, don't forget to subscribe the channel in order to stay updated with upcoming and interesting case studies. Moreover, I have given some case study link in the description of this video. With that being said, let's jump into this video. In 2007, Intel Corporation, the American multinational semiconductor manufacturing company, was in the process of developing a low-power processor chip called Atom. Although Atom was only a product line extension for Intel, it had a significant difference in its unit economics when it came to supply chain costs. Intel's traditional processors were sold for around $100 per unit. On an average, the total supply chain cost and inventory costs per unit of Intel's traditional processors worked out to be 5.5% of the unit cost. This was justifiable given the high cost of conventional processors. But Atom had an introductory price of $20 which was expected to fall to $10. At such low prices, the supply chain expenses were working out to be 40% higher than the affordability target. To maintain the same revenue to supply chain cost for Atom, there had to be a radical approach to establishing the supply chain of Intel's new chip. Moreover, Intel expected to ship around 20 million Atom processors within the first year of its launch in 2008. Intel was a market leader in microprocessors which were used in personal computers, servers, and heavy computing. It had sensed the need to develop a product which could be used in mobile devices, consumer electronics, and light computing. Such devices represented an annual revenue potential of $10 billion or more for Intel. The Atom chip was also viewed as an enabler to lower computing costs when used in low-end laptops, which, in turn, could increase the penetration of computers in the emerging $40 billion market. It is seen as an opportunity with potential to double Intel's business. So somehow, Intel had to reduce the supply chain costs for the Atom chip. The chip had to work, so Intel could make no service trade-offs. With each Atom product being a single component, there was also no way to reduce duty payments. Intel had already whittled packaging down to a minimum, and with a high value-to-weight ratio, the chip's distribution costs could not be pared down any further. The only option was to try to reduce levels of inventory, which, up to that point, had been kept very high to support a 9-week order cycle. The only way Intel could find to make supply chain cost reductions was to bring this cycle time down and therefore reduce inventory. Traditionally, designing a chip took several years and hundreds of engineers. Any new version of an Intel processor had to be designed as per the required specifications. Intel's senior designers took around a year to build such specifications by taking inputs from all stakeholders. The key specifications included chip size, number of transistors, and production and testing factors. A detailed document of the specifications ran into thousands of pages. In the case of Atom chip, Intel decided to try what was considered an unlikely supply chain strategy for the semiconductor industry: make to order. The company began with a pilot operation using a manufacturer in Malaysia. Through a process of iteration, They gradually sought out and eliminated supply chain inefficiencies to reduce order cycle time incrementally. The make-to-order model initially brought the supply chain cost per chip down to $1.40 or so. Intel expects to get that to under $1 sometime in 2010. Intel executives visited several customers to get direct feedback and discuss how Intel could better serve them. The goal was to improve business processes based on real customer needs. During these visits, customers indicated dissatisfaction with the order fulfillment process. A typical response to changing an order could take up to 1.5 weeks. During that time period, the customer didn't know if Intel could promise to deliver the product when requested. The delay in response was due to the need for multiple levels of approval. Additional delays stemmed from multiple order changes. In response to this feedback, Intel launched the Just Say Yes program, which led to sweeping changes to the microprocessor fulfillment process and an intense focus on customer responsiveness. The program would focus on the following elements. 1. Improve Intel's ability to respond quickly and positively to change order requests. 2. Respond to customers within 24 hours with a committed dock date, which entailed committing to a date for product availability and having products available in the warehouse within 3 days. 3. Reduce inventory levels. 4. Reduce errors in demand forecasting. 5. Implementing new supply chain performance metrics. 6. Replacing manual processes with automated processes. 7. Reducing the time between when a customer places an order and when the product is received, known as the order horizon. 8. Improving internal efficiency. To design a new supply chain from scratch, Mr. Kelso, Senior Supply Chain Master, started off by forming a team for the task. He selected the best people from Intel for the project but only requested half their time. The timeline given to Kelso's team was 6 months and the project was called Low Cost Supply Chain Project. It was understood that something radically different would be required to achieve the cost reductions. The team came up with a one-page document, which captured how the product flowed through the stages of a supply chain operations reference model that focused on plan, source, make, deliver, and return. This led to a team charter to create the ability to deliver up to an additional 900 million units a year at $10 product costs by 2012, while increasing customer service. Through its incremental approach to cycle time improvement, Intel eventually drove the order cycle time for the Atom chip down from 9 weeks to just 2. As a result, the company achieved a supply chain cost reduction of more than $4 per unit for the $20 Atom chip, a far more palatable rate than the original figure of $5.50. Thank you everyone for watching this content. I hope you like this video. Then please give this video a thumbs up and share this video with your friends. That would mean a lot to me. And do not forget to hit the subscribe button and subscribe the channel for more such interesting and engaging case studies on strategies used by various organizations across the world.